So in the previous video we already started to have a look at types and all the benefits of types, and we created the string variable and we assigned it string, and we noted that for some of these basic types it's better to just let Typescript use Typescript inference, so you can infer like the basic strings, the booleans and all that sort of stuff, so we don't necessarily have to assign it explicitly like in this particular case. And we'll notice though, one thing to notice is that if the benefit of TypeScript is we can have IntelliSense for the string, so if we do dot and we can take a look at all the methods, and these are methods that work on strings, so like splitting, slicing and all that sort of stuff. But we don't even necessarily need to have this here, because TypeScript can see, okay, there's a string, so he just infers there's a string, and these types should still all work on these methods. String methods should all still work, and they do. So we can sort of see a benefit of using types, and one of the main benefits is, detecting errors before they actually happen. So let's go ahead and we'll just declare two numbers, because we're going to make a simple adding function. So we'll have number 1 equal to 4 and number 2 equal to 5. And straight away, something to note is if we hover over it, we get const number 1. Okay, so it still does infer the number type in this case, but when you hover over it's not showing it. I was expecting that it would, similar to the string, but let's just create our function, add. So we'll add two numbers, x and y, and so this is just all standard JavaScript at the moment. And this is just returning x and y, and something we may want to do is we may want to just console log, so clg the return of the add for number 1 and number 2, and we can save that. And okay, so let's just do a TypeScript compile and we'll watch it, so it will continuously update for us. And one thing to note already is that we do get this error, this TypeScript error. So the TypeScript error, and I'll refresh this as well. Okay, so the TypeScript error is essentially, it's just adding some safety to say that we haven't specified the types. So we've seen adding types to properties. In functions we also can do a particular type that that function is expecting. So we could have the type number here and the type number here, and then we notice y colon number. So now if we save that, there's 0 errors, and then our code should compile. So it compiles it into ES5, and this should be displayed in the browser. Oh, sorry, I think I need to reactivate live server, because there was the error before. I had to close and reopen the window. So let's go into the HTML file and open live server. So now that is open, we can press F12 for the developer tools, and then we get 4 plus 5 is 9. And okay, so let's go ahead and close these files so we don't accidentally type in the JavaScript. Now if we were to do a console log, now technically this function, if we added two strings together, it will concatenate them together, and if we accidentally did that, say we had number 1, like we had 1 as a string or something like that, it would immediately spot that. But if this was not number, this was just standard JavaScript, then it wouldn't necessarily spot that when we compiled it. But Typescript points out that we should give it a type anyway, so we can go ahead and have that type safety. Okay, so that is the number type. And one thing with functions is when they return something, so in this case we're using the keyword return, we can specify what we're expecting to be returned. So in the function, after the arguments, we can use this colon, and then we can type number, because we're expecting a number plus a number equals another number. And that's just to add even more type safety to it. So that's the number and a basic function type. So now let's just comment that out for now, and we'll comment the numbers out as well, and we'll just order this as so this is basic types, and this particular type is the number type. And the next type we can take a look at is so let's take a look at the string type. And these are all basic types that you would already be familiar with. It's just using them in the context of TypeScript. So we'll just have a string here saying hello world, and we might do the boolean as well. So get 2 things done. And I might create a function that converts a string to uppercase. Depending on a certain situation. So how would we do this? We can go function, and let's just say get string, and okay, so for the particular string, so for the string, which is going to be your type string, and we're going to have this flag, this uppercase flag, so that's going to be a true or false, so that's going to be a boolean. For that, if uppercase evaluates to true, then what we'll do is we'll just return the string to uppercase, so we can use that IntelliSense from TypeScript because we know it's a string, so we can just go and choose to uppercase. And if that's not true, we'll just return the string as is. And note, because we're returning something, we're returning a string, we have to have this return type of string. So that's that's how we go about using the string and uppercase, the string and boolean types. And we will we'll console log this getString method, and we'll pass in string1 and upper for the first one, and we can, we don't have to have the variable, but we can just pass in hi, and this can be just true. So we'll save that, take a look at our code, and we can see hello world, the string's printed out, and it's not uppercase, and hi is in uppercase. So that's sort of the string and boolean. Okay, so the next thing I want to go into is an object. So this will be the next simple basic type, and everything is an object in JavaScript. So let's just take a look at objects. So we're going to say we're going to have a constant object, and it's going to be a user object, and the user is going to have an ID, and that's going to have a number. So okay, this is the difference between this format and an object is that an object has comma separations of a key value type, but we got like a key type pair rather than key value pair with sort of the semicolon rather than the comma. So we'll also have a name of the user, which will be string, and what we'll do is we'll set this equal. So this is the type there, this is the object itself. So for the object user with an ID 1 and a name of John, we can have this sort of type declaration of the object in this sort of format. This isn't necessarily something we want to do for these basic types of number and strings and stuff like that. It's something we would want to do if we're creating our own type, and we need to, and that's something we'll get into in a bit later. But I just wanted to sort of show this way, as it will be used later on. So let's just go ahead and just copy that. And rather than having this user here of the type of that particular object type we created, we could have something like this. So there is an object type, and that's just an object, curly braces, key value pairs, and again that isn't necessarily something we would want as well, because if we're doing something like that, we may as well let Typescript use type inference. So user dot something, we can't really see any IntelliSense for that. So let's go ahead and get rid of this object declaration, and we can see that constant user is a type of object, and if we delete that, it sort of shows us the type of the user is more in this previous format. So the previous format, it does have IntelliSense because it's declared for that particular ID and name, but if so yeah, we can see that it's this and this are essentially the same thing, but you may as well just keep it simple, and it's actually recommended and best practice to avoid overcomplicating it. Okay, so I guess the next thing I would want to talk about is arrays. So an array, so we know what an array is. So let's just say we let languages, we say let languages, and then languages equals JavaScript TypeScript. And what we can do in this case is we can see that all of our array elements have a string type. So this we we can type in that languages is the of type string, and then it's not just a string, but it's an array of strings. So we can use the array square brackets, and that sort of lets JavaScript know that everything in the languages array must be of strings. So if we do something like have this 5 here, we get this error. It's not assignable to the string type, and that's good, that's what we want. Let's say that we did want to assign, so I might just copy this and oops, do a Shift-Alt down, and I'll comment this out by highlighting it and doing a Control/. Let's say I did want this 5 to be in here. I could, for now, I'll just say it could be of the any type, and the any type isn't necessarily something we want to be using. So in this case we have the array methods and all that stuff here, but just the any type in general. So let's say, for example, const string 3 of the any type equals string 3 and string 3 dot. Notice that we actually lose some, TypeScript doesn't know what type it is, so it can't display the methods that are associated with string. Rather, if we just had the word string there, or even better yet, use type inference to let TypeScript know that it's a string, and then that will immediately display the methods associated with the string. So we don't want to lose any data whenever possible. So for that reason, we really want to avoid this any type, but in certain situations we may need it. And even in something like this, we can, have multiple types with, unions and stuff like that. But that'll be something we'll get into in the more advanced types. So I just wanted to show off the array methods, the array types. So we can comment that out for now. And yeah, TypeScript, it identifies the correct type, and it can show the methods. For example, if we to get our languages back, we could, because it's an array, we can go through the languages. Languages dot for each, and for each language, if we wanted to, we could just do a console log of the language, and we can use the toUpperCase method. And if we run this and we look in the browser, we can see that we've gone through each of the array elements and we've console logged it out in uppercase. So, okay, so we've gone through the basic JavaScript types. The standard Boolean, string, array, object, number, and we've seen the importance of types and the benefits that has for type safety and intelligence and all that sort of stuff. But now we can sort of start to take a look at some of the extra types that TypeScript give us. So, okay, I think a good place to start would be a tuple, considering we just did arrays. So what is a tuple? A tuple is essentially, it's an array of a fixed length and a fixed type. And the idea is that if we knew something in advance ahead of time that we didn't really want to change, we could sort of create it such that nothing more can be added to that particular list. So let's see, if I make an item and I'll just say that that item is an array and it has a number and then it has the product name. Let's say that an item is always in this form. There's always a number and there's always a string. So there's a number ID and there's a string associated with the name of the item. What we can do is we can use this sort of array, and opposed to a regular array where we have the name of the array type outside of the brackets, we can specify these inside. So we can say number and string like that, and that's a tuple. And it's good in the sense that we can avoid, like, we can't rename the socks to a number, for example. So if we went item 1 and set that equal to 3, that's an error because that's not a string. But we could update our stock, and these could be now shoes, and that's all well and good. There's also, so it keeps the same type, and it also, for each particular element, and it also should, if we did something like try to reassign item to equal to for socks 5, we can't do that. And okay, that's because it's a constant, so that's not a Typescript thing. But even if we made that let and then reassigned it, it's not of that length, so can't and shouldn't be able to do that. So that's good. So that's an advantage of a tuple. Okay, so the next thing will be an enum. So what is an enum? So enum, this is going to be our first sort of custom type, and custom types should be in Pascal case, meaning the first letter is uppercase and every word after that is uppercase, and that's sort of like a convention used. But anyway, what it is so the numeric enums are used to store string values as numbers. So we can think of these as like, let's say we're building a website and we wanted to target our ads to adults rather than children or elderly. If we had like a category group for each of those ages. So let's go ahead and we'll make this enum with the keyword enum, and so we use a capital A, and that's true for other things we'll see, like classes and interfaces and stuff like that. But the idea is, okay, so let's say and all of the categories within it should also be uppercase. So all the values within the enum should be uppercase as well. That's just a convention. And this just really spells out that they're sort of constant. So we'll have child, adult, and elderly. So what this enum is saying is that, the first category is children, the second category is adults, and the third category is elderly. And these these are like readable categories by other developers essentially. So if you know, if you had a larger website and you knew that you wanted to sell to adults and you're looking at the category 1, well then you have to sort of deduce what one means and all that sort of stuff, and if compared to if you had it spelt out like this, so it's sort of like a string representing that number, it's more human readable. So let's use this enum and sort of see an example of why we would use it. And yeah, it reduces the need to define and manage numbers, and also only these numbers are allowed, so we can't add some random fourth category or something like that. But okay, so let's say we make our constant user again with an ID of 1, name John, and this time we'll have this age category. That will be a lowercase a, but of this enum age category type, we can say that the age category for the user is an adult. And we can also, you know, if we console log this, so I can do a CLG, and I console log this user, I save it, compiler compiles it with the watch, we can see that we've got this object ID1, name John, age category 1. So when we're typing this out, we're like, okay, the age category is an adult, but this refers to a 1, and child will be 0, and elderly would be 2. But we can also do things like we can change the numbers, and if we change the first one to 4, that means by default it will just, the next number will be 1 after, and there'll be 1 after, so there'll be 4, 5, 6, meaning that adult will be a 5, and that's the new category, the number of the category representing the string. And we don't have to be limited to numbers as the groups if we don't want to. We could have this elderly old thing here like this. So we'll have 4, 5, and if we change this age category in the user object to elderly, then we can see the age category is old. So enums are great for human readable code, for categories, for certain numbered categories with string descriptors. And yeah, that sums up the basic types in Typescript. In the next video we'll take a look at some of the more advanced types and some of their advanced types in conjunction with certain functions.